For any triangle ABC, we need to show that the following is true. Let us begin. Now, before beginning, let's talk about few terminologies. Let us consider a triangle ABC. Here, the sides opposite to angle A, B and C are represented by the letter ABC in the lowercase respectively. For this particular triangle, if we take the sum of its sides, that is A plus B plus C, that's going to give us the perimeter of the triangle. What we'll do, we'll take the half of that perimeter and that gives us the semi-perimeter, which is denoted by the letter S in lowercase. Now, using this information, we can derive the tangent of the half angle of A, that means tangent of A over 2, that's given by the square root of S minus B times S minus C divided by S times S minus A. Similarly, we can define the half angle formula for tangent B over 2 and tangent C over 2. Now what we'll do, we'll start for the first expression. So let's start with B plus C minus A multiplied to tangent of A over 2. This is going to be equals to, what we'll do, we'll rewrite a B plus C minus A. We can rewrite it as, we're going to add A to it. And then also subtract A from it. This is going to give us negative 2A plus B plus C minus 2A. Multiplied to tangent of A over 2. We'll use this formula. We have the square root of S minus B multiplied to S minus C whole divided by S multiplied to S minus A. This will be equals to, now A plus B plus C, if we use this formula, this is going to be 2 times the semi-perimeter minus 2A whole multiplied to the square root of S minus B times S minus C divided by S times S minus A. That will be equals to 2 times S minus A multiplied to the square root of, now let's do one manipulation here. We're going to multiply the numerator and the denominator with the denominator. That means with S times S minus A, such that we get S times S minus A multiplied to S minus B times S minus C divided by, we'll have S squared times S minus A squared. This is going to be equals to, now what we can do, we can since S squared times S minus A whole square is a perfect square, we can pull it out of the square root. That's going to give us 2 times S minus A divided by S multiplied to S minus A multiplied to the square root of S times S minus A times S minus B multiplied to S minus C. Now, this expression, the square root of S times S minus A, S minus B times S minus C, this is the area. This is the area of the triangle ABC, which is also sometimes referred to as the Heron's formula, which means now our expression reduces to, so we can factor out S minus A. This is going to give us 2 times delta, where delta is going to be the area of the triangle ABC divided by S. In other words, we have showed here that B plus C minus A multiplied to tangent of A over 2. This is going to be the same as 2 times the area of the triangle divided by the semi-perimeter. Okay, now let's go to the next expression. We're going to label this as number 1. Now, in the next expression, we have C plus A minus B multiplied to tangent of B over 2, which means we can rewrite it as A plus B plus C. What we're doing here is adding an extra term B, but we also have to subtract it. That means we'll subtract 2B from it. This is going to get multiplied to tangent of B over 2. So tangent of B over 2, the formula is going to be S minus A multiplied to S minus C whole divided by S times S minus B. This is going to be equals to 2 times S minus B multiplied to the square root of, so what we'll do, we'll multiply the numerator and the denominator with S times S minus B, making it S times S minus A times S minus B times S minus C whole divided by S squared times S minus B whole squared. So this is going to be equals to, we have 2 times S minus B multiplied to delta over S times S minus B, and that gives us 2 delta over S. So similarly, which I'm leaving it as an exercise for you to try out. Similarly, for the expression a plus b minus c multiplied to tangent of c over 2, we can show that this is going to be also equivalent to 2 delta over s. So here we have successfully showed that. Hence, we have showed here that if we take the expression b plus c minus a multiplied to tangent of a over 2, this is going to be the same as c plus a minus b times tangent of b over 2, and also it is going to be equal to a plus b minus c multiplied to tangent of c over 2. Hence proved.